Hi, we're going to talk about the origin of the Earth, how we got here, the story of fire. So, in order to do that, we got to talk about how the Earth originally formed. Heat and gravity shaped the evolution of the planet. They used to think that rocky planets were created by a rapid gravitational collapse of a dust cloud, giving rise to dense orb. But in fact, more recently, we figured out that Otto Schmidt was correct. He's a wonderful Arctic explorer who also thought that the planets grew gradually in size step by step. Otto Schmidt was responsible for creating the space program in Russia. But his idea that the planets were being hit constantly eventually came to be the facts that we now realize are probably true. I'm sorry to say this was a very abusive time for the Earth. It was constantly getting hit by other planetoids. Things the size of the moon or Mars were hitting the Earth constantly, and it eventually made the Earth very, very angry. Had a huge magma ocean that was created underneath the surface of the planet, which continues to cause most of the planet's characteristics today. When did this all happen? We actually can measure the gradual drop from uranium to lead. That will give us an uranium clock that tells us how old the Earth actually is. Patterson actually came up with the uranium clock, and he came up with the original age of the Earth at 4.55 billion years. He then went on to fight lead and gasoline, and then also was part of the Manhattan Project. But he's the famous scientist you never hear about. So the Earth was basically abused for about 150 million years. And then there was a lot of lava that came up to the surface of the Earth and gradually began to cool. That cooling created this crust. We kind of have the creme brulee, if you will, of the Earth's surface, gradually coming up, cooling, and becoming the crust that we think of as the surface of our Earth, which is just really just the cool crust on top of a lava filled Earth core that's still gradually grinding its way around and underneath. So this is the Mariana Trench. This creature lives in the Mariana Trench, and it's being ground down underneath another part of the surface crust. So things that we think of as permanent, like the Himalayas, are actually just the pushing up of the crust. And if you have a place in, say, Iceland, you might want to think about your real estate in Iceland because it can move as much as 7 meters. You might lose half an acre this year because the Icelandic plate is very, very unstable and it's constantly grinding things down and under. There's a lot of good stuff here for your geologists and some good jokes about there if you want to read the whole slide. But if we look at this, the bottom line is there's just one tiny little piece called the Acasta gneiss, which is actually still remaining of the original crust. Everything else is gone. It's all ground back under. So once the lava formed the crust, then we had all these gases erupting from the center of the core, but no oxygen. So basically, at that point, we were like Mars or Venus in terms of our atmosphere. Nothing else, nothing could live that we know of could live like that. So what really started to make things green was actually pond scum. Basically, cyanobacteria were actually they evolved and they formed and then they generated massive, massive pollution called oxygen, which is actually what causes all of the green that we see today. But none of that was originally on the Earth. And so the tectonic plate model means that we were all part of one central big chunk, if you will, of crust, and then it's gradually separated out. Here's 3.3 billion years of our supercontinent traveling around and showing you different areas. And here's a wonderful shot of about 100 million years ago. Remember, this is when we had no ice. So when you get rid of all the ice, look what happens to your continents. Have a look at that. It might be our future. Yeah, I hear you guys saying, well, this has nothing to do with Maine. In fact, we were massive super volcanoes about 400 million years ago. If you look around, you'll still see lava beds everywhere. You can see a volcanic caldera here. And of course, here's Mount Desert Island. It's about 15 miles long and 15 miles wide. We're talking about a super volcano that came up out of Mount Desert Island and blew the whole place to heck. And you can actually see that with Acadia, all of the lava flows and the metamorphic and the gneiss, all of the different flows that happened during that explosion are still visible today. Thank you very much.